Thank you. Yes, today's topic is evaluating the effectiveness of a mathematics diagnostic test, and we are presenting this today. By myself, I'm Leo, and also my colleagues are Eleonora. We are both lecturers in mathematics education in King's International Foundation program. For those who are not familiar with the International Foundation program, International Foundation program is a level 3 education program provided. You can say it's a pre-university program provided for particularly international students who are from countries with their high school systems, which are regarded to be 1 year short when compared with the UK high school system. So when those students from other countries want to apply to UK universities, some of them for those missing that 1 year gap, they will have to take a pathway program like the International Foundation program to make up those knowledge gap, so as to prepare them for undergraduate studies in the UK. Actually, you may have some students in many universities from International Foundation program. Some universities also have their own program, and we are I and Eleonora are particularly teaching the mathematics modules in our King's International Foundation program. So next. So today's topic, we are actually talking about a diagnostic test. We actually have tried to pilot this year for our students. We particularly want to have a diagnostic tools to see what is the knowledge background of students. So today we will split the discussion in the following structure. First, I'll tell you what we have done about the studies and the diagnostic test design itself. Then Eleonora, we start with some analysis on the explanatory data analysis and item analysis. Then we will move on to the statistical analysis to provide the result, what we can find from the data we collect, and of course that will lead to our conclusion. So the background of the diagnostic test. Well, diagnostic test is to provide early information. We particularly make this diagnostic test at the beginning of the program, such that it can provide us early information into the students' mathematical ability and their prior knowledge. We are particularly interested in looking at whether there's a gap between what those students learned before they come to a program and whether they are up to what we expect them to be able to do when we start teaching the new topics in our program. So, and it also helps us to identify strengths and weaknesses of our students. This test we have adopted is particularly for our module called Maths for Social Science module, and this module is particular for those students who are prepared for progressing to undergraduate programs in economics, business, or other social science studies. So they need some knowledge in some mathematics and also some statistic analysis, statistic knowledge. So and we the test itself of the results actually we have helped us to find what is the knowledge gap, and also this test also help us to, because we run it the first time, we also want to use this the results to tell ourselves what else can we improve the test, so that in the future we can design some tests which are provide more relevant information. So yes, and the test itself was arranged last year in October, and as I said, it's provided to our 1 year mathematics foundation module in our King's Foundation program. And the test was given to my and Eleonora students, which in total over 100 students. Ignoring some samples which are not usable, we have collected about 100 student data, and they are aged 17 to 29. And they are, as I said, they're all international students. It means that none of them are from the UK. They're all international background. The test itself, we have two sections, 10 multiple choice and 4 short answer questions. The test is of level of around GCSE or below. We did not really test, we try to understand whether the students got the basic knowledge, even not as high as A level, to see whether there's a substantial gap or not, and they cover some basic concept, mathematics concept like basic arithmetic, algebra, and number operation, etc. We particularly is allow use of calculator or dictionary. That sometimes is allowed in formal exams, but we want to see without such tools, what can they do? So that's basic fact about the test. Then I think I will move the mic to Eleonora, who will present some of the results.
Perfect. So I'll start just with an overall picture of the test results. So we can see here, this bar chart shows the distribution of the total scores, and we can see here it ranged from 6 to 14, and that the distribution of the total scores were negatively skewed, which means that most students performed quite well in the test. So for example, we have that 30 students scored a 13 out of 14, which was the most common score. But on the other hand, we also had 4 outliers. We had 2 students who scored 6 and 2 students who scored 7. So while the overall performance was quite strong, we felt that it was very important for us to look closely for any gaps in the students' prior knowledge that would really impact their learning. So then afterwards, what we did was to look how the students performed by nationality. So here we focus on Chinese, Saudis, and Turkish students, as these were the only really significantly large groups in our cohort. We noticed, for example, that half of our students, half of the Chinese students scored 13 out of 14, and that 6 of the students who got full marks were also Chinese. And finally, we can see here that no Chinese student scored less than 10. On the other hand, we noticed that 75% of the students who scored less than 10 were Saudi and Turkish students, and we also noticed that 3 out of our 4 outliers also belonged to this group. So the test results here, they suggest that background factors such as nationality may have influenced how our students performed on the test. So next, what we did was we broke the test down into individual questions to see where our students were struggling, and also to review the content and the quality of the test. So this bar chart just shows the number of students who got each question right here in green, and the number of students who got each question wrong in red. So we can see here that over 95% of the students got questions A1 to A5 right, which suggests that maybe they were likely to be too easy to be useful for us diagnostically. And we also noticed, for example, that 67 students got question B3 wrong. And we also had 2 other items, A8 and B2, which had quite a high failure rate. So this breakdown really gave us information into the quality of our individual questions, and also as it gave us a better understanding of our students' prior knowledge. So now, when we looked at this item performance by nationality, we did notice some patterns. So for example, we noticed that 6 out of our 15 Saudi students got item A6 wrong, which suggests that they had a bit of difficulty dealing with nested brackets. We noticed that half of these students also struggled with item A9, which involves just converting a very simple fraction into a percentage. We also noticed that although our Chinese students generally performed quite well, they got items B2 and B3 wrong, quite a high number of them. So this we assume that this might be associated with the fact that they were less familiar with concepts like expressions such as decimal place and significant figures, which was quite interesting to see. So we were able to use this item level data to give our students some feedback very early on in the module. And what we did was we shared with the students some extra material, very specific, to help them address these gaps. So in order to measure how easy an item is formally, we need to look at what facility value of each question. So the facility value, when we have dichotomous items, such as the ones we had on this test, where you score 1 if it's correct and 0 if it's incorrect, the facility value is really just the proportion of students who got that item correct. So if we have an item has a high facility value, it indicates that this item is quite easy. If the item has a lower facility value, it indicates that it's a more difficult one. So for example, item A9 here has a facility value of 0.8, which tells me that 80% of the students got this question correct. On the other hand, we have item B3 had a facility value of 0.33, which made it the most difficult item in our test. So this metric really helped us assess which items were performing as we intended and which ones we needed to revisit. So finally, what we did was to group our students into quartiles based on their total score on the test. And then we plotted these item characteristic curves that show how the facility value changes with our students' abilities. So for example, and so this allows us really to see how well an item is discriminating, for example, between low and high performing students. So for example, my item B3 here in blue, we can see here that it displays this really clear increase in facility. It's almost a straight line. So for example, we have that only 5% of our students in the low quartile got that question right, compared to almost 70% of the students in our top group. So this suggests that our item B3 did a very good job at distinguishing between these different abilities. We can see, for example, as well, that item A8, also here in light pink, has quite a similar pattern, showing that as you increase, that the facility value increases as the student ability increases as well. We have that item B2 here in dark pink has quite a different pattern from the other ones. So for example, B2 here, you have that quite flat, remains quite flat between the first and the second quartile, and then it rises quite sharply and then flattens up. So this means that this item B2, it's quite good at separating between the bottom 50% of our students and the top 50% of our students. And finally, we saw quite a few items with a similar pattern as my item here, A9 in green, where you can see a sharp increase from my first to second quartile, and then it levels off. So these items were good at discriminating the students who were at the bottom of 25th bottom part of our students. So this pattern was really important for us when we were trying to refine the test, and especially the design of the test, because what we really want is items that have a straight line that really clearly increases the facility value as we increases the student's ability. And they helped us really to identify the items that were contributing in this meaningful way to identify these different ranges of abilities. And then finally, we looked at the statistical analysis, how we deal with this data, especially on the item level. So, for example, here we calculated how. So, in order to better understand how each question was reflected our students' overall performance, we looked at these. The correlation between each item and the total score, but here we excluded that item from the total score. So this is what we called the corrected total score, and that's very important because it's in order to avoid artificially inflating the correlation. And this is particularly important because we only have 14 items. So we use the Pearson correlation coefficient in order to really measure how strong the performance on one particular item is associated with the overall performance. So, for example, here we can see that most questions did quite well at assessing students' abilities. For example, item A7, A6, and A9, they were quite good. So that suggests that that students who answer these questions correctly generally performed quite well across the whole test. And all these items had a statistically significant correlation, except questions A1 to A4. So this was really helpful for us to identify the items that were performing well and the ones that we clearly needed to replace in future iterations of our test. So now I'm going to hand over to my colleague Leo, who will talk through the rest of the statistical analysis that we've done.
Okay, thank you very much, Eleonora. So, Eleonora has provided a very detailed analysis of the test design itself to see which question are particularly useful in future, and some may have to be redesigned. So I'm going more into the result of the diagnostic test we have done and what we can conclude from the test. So actually, I put the conclusion here first. The conclusion is this time the diagnostic test is found to be a very significant in helping us to predict the result of all the individual assessment of the students throughout the year. And also it is a very significant factor in helping us to predict how likely the students can achieve A, B+, or any grade below B. So the basic conclusion is it is potentially a very useful tool in helping us to identify students who may need additional support from the start of the program. So now I'll move to the more detailed result. First, we actually know in this program, in our modules, we have in total basically 4 individual assessment. Well, the first result here, we noticed that the diagnostic test result actually is similar to what Eleonora presented earlier. We noticed that the Chinese students perform particularly more positively in the diagnostic test, while Turkish and Saudi Arabian students tends to score much lower. Well, it could mean that actually we do notice that students, it may actually be regarded as evidence that students actually coming to our program did have a very different education background. Their high school education may actually prepare them very differently. So there may be quite some gap. Well, you may be tempted to believe that then that becomes the only factor we should look at. So we should provide more support to the Saudi Arabian students or something like that. But when we actually do another analysis for the students based on their background, nationality, and the actual result during the year, we find that nationality is no longer a significant factor in predicting the result. So it may mean that even their background may be different, but it turns out that that background may not be the most significant factor in affecting how well they can perform in the year. So then what can be a significant factor? It turns out that the test result, the diagnostic test result itself, is a very strong indicator. So first, we find that the diagnostic test result has very high correlation in any of the actual summative test results. So you can see that the diagnostic test result have a very positive correlation with our test 1, test 2, and test 3, and also the final exam, which is not presented on this page. And the significance, for those who understand, the significance is very high, or the p-value is much smaller than 0.01. So, and then when I actually run it against, when I run regression for that next page, when I actually run some regression on the diagnostic test result with all the assessment, summative assessment results, and also the final exams, and also the overall grade of the students at the end of the module, we find that also all the results are very significant. You can see that the p-value are very, very small. Okay, so it means that the diagnostic test result, students getting low diagnostic test result, basically would not be able to get a satisfactory grade, and those getting a high diagnostic test result are very likely to get what the grade they need for progression. Okay, so what is the conclusion from it? The conclusion is the diagnostic test is a very good and very strong tools which can be very useful in helping us to identify who are the students who may need further support from the very beginning, because they are found to have very high highly positive correlation with any of the actual assessment in the year. So it shows that it is a very potential good. It is a tool with very good potential to be used as diagnostic test purpose. And well, we see some pattern about the nationality, but we see that it may not be the most important factor when actually deciding whether to support which group of students to support. And also another part of this particular pilot test is we actually noticed that some kind of questions are particularly useful in helping us to design our future diagnostic test, and some of the questions may be not suitable in future that may need to be reconsidered. So what I actually can respond to some of the questions here, which basically is related to the conclusion. One of the questions is about whether we are using this diagnostic test result to tailor learning intervention and support service for students. Well, because this time when we first ran the test, it was quite a pilot. We did not have a very thorough plan of what to do with the result. It turns out that the result is so strong that it seems that with this result, we can actually think of what to do in future when we rerun this test again. If we know which group of students who need the particular additional support, maybe this group of students can be provided the additional support in future. That is something we are now thinking about, and possibly we will advise to suggest to the department to see whether that kind of additional support can be provided. So actually, this test, we see quite a lot of potential there. The result is pretty strong, and there are actually quite many many features which is very useful in the future. So I think maybe I'll just stop the presentation here. I noticed that time is almost up.
Thank you so much, both of you, for an overview on your mathematical diagnostic tool at King's College London and your overview of the project.